Hi everyone, my name is Krishna Veni. I am working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. Today in this session, I am going to discuss about the analysis of coal. What is analysis of coal and why we have to do the analysis of coal? Analysis of coal is done to test the quality of the coal, to rank the coal. Okay. Now coming to the analysis of coal, we have two types of analysis. One is proximate analysis and another one is the ultimate analysis. In proximate analysis, we will determine the moisture, volatile matter, ash and the fixed carbon. The ultimate analysis is also known as the elemental analysis, in which we will determine the carbon, hydrogen, nitrogen and sulfur elements present in the coal. Okay, first we will see about the proximate analysis. In proximate analysis, first we will determine the moisture content of the coal. Okay, for this process, the procedure is we have to take 1 gram of the dry powdered coal sample into a silica crucible, which is kept in a hot air oven for 105 to 110 degrees centigrade, which is maintained for 1 hour. The hot air oven should be maintained at a 105 to 110 degrees centigrade temperature, and the crucible is allowed to remain in the electrical hot air oven for about 1 hour. And then it is taken out and cooled in a desiccator. Okay, after cooling, the coal sample is weighed. Okay, next, the percentage of the moisture is calculated by using the formula loss in weight by weight of the coal taken into 100. This is how we can calculate the percentage of the moisture. Now, what is the importance of the proximate analysis? Okay, the excess of moisture is undesirable in coal. Why? Because the excess of the moisture is present in the coal will decrease the calorific value of the coal, and it will also quenches the fire, means it will use the excess of fuel. Okay, that's why we should not have excess moisture in the coal. Next, this is the apparatus which is used for the determination of the moisture. This is the tons with the help of which we can hold the crucibles. These are the silica crucibles in which we will take the coal samples, and these are the desiccators in which we will keep the silica crucibles to cool down the coal sample. Okay. Next, volatile matter. The dried sample which is left over in the point 1, means in which the moisture is determined. Now it is covered with a lid and placed in an electrical furnace maintained at 925 degrees centigrade for 7 minutes. Okay, after the 7 minutes, the crucible is taken out. First it is cooled in air and then it is kept in a desiccator. Next, loss in weight is reported as volatile matter on percentage basis. We will calculate on percentage basis. The formula is loss in weight due to removal of volatile matter by weight of coal sample taken into 100. The significance is lower the volatile matter, better the rank of the coal, means the coal sample should contain the less volatile matter. Next, ash content. The residual coal which is left in the crucible after the determination of the volatile matter is then heated without lid in a muffle furnace maintained at 700 degrees centigrade for half an hour. After half an hour, the crucible is taken out and cooled first in air, then in desiccator, and the sample is weighed. Heating, cooling and weighing is repeated till a constant weight is obtained. The residue is reported ash on percentage basis, like percentage of ash is equal to weight of ash left by weight of coal taken into 100. This is how we will determine the ash. Next, fixed carbon. To know the percentage of the fixed carbon, we have to minus the percentage of moisture, volatile matter and ash from the 100. This is how we will get the percentage of the fixed carbon. High percentage of fixed carbon is desirable in the coal. Okay, a good quality of coal will contain high percentage of the carbon, less moisture, less ash content, less volatile matter. This is how we will do the proximate analysis. Next, we will see about the ultimate analysis. This ultimate analysis is also known as the Elemental analysis. First, we will determine the carbon and hydrogen. To determine the carbon and hydrogen, we have to take a known amount of the coal in a combustion tube. This is the apparatus which we will use for the determination of the carbon and hydrogen. Okay, this is a combustion tube. Here the platinum container will be there in which we will keep the coal sample, and we will pass out the pure dry oxygen through it. Here the furnace is there in which the coal sample will be mixed with the pure oxygen, and the carbon and hydrogen which are present in the coal sample will be converted into CO2 and H2O respectively, and they will be passed out into the CaCl2 and KOH solution respectively. Next, what will happen? The gaseous products of combustion are observed respectively by KOH and CaCl tubes. Okay, the increase in weights of these are then determined. For example, carbon will be mixed up with oxygen and converted into CO2. The hydrogen will be mixed up with oxygen and will be converted into water. The percentage of the carbon is calculated as increase in weight of KOH tube, means the CO2 gas will be absorbed by the KOH tube into 12, which is the molecular weight of the carbon, into 100, means we will calculate the percentage basis by weight of the coal sample taken into 44. 44 means the molecular weight of the CO2. This is how the percentage of the carbon will be determined. Next, the percentage of the hydrogen. Increase in weight of the CaCl2, calcium chloride tube, means the H2O, the water in the form of vapor will be absorbed by the CaCl2 tube. Into 2 means the molecular weight of hydrogen into 100 by the weight of the coal sample taken into 18. 18 means the molecular weight of the water. This is how we will calculate the carbon and hydrogen present in the coal sample. Next, the determination of the nitrogen. Nitrogen is determined by using a special apparatus called the Jaldal flask. Jaldal flask is a long-necked flask. Okay, it is a long-necked flask. First, we have to take 1 gram of the accurately weighed powdered coal sample into a Jaldal flask, and it is mixed up with the H2SO4, K2SO4 and CuSO4 solution. Then what will happen? The coal sample will become clear. It is treated with excess of NaOH, and ammonia is distilled over the absorbed known volume of standard acid solution. What will happen? The coal sample is treated with the concentrated sulfuric acid and the K2SO4 CuSO4 solution. It will be converted into clear solution. When it is treated clear solution, when it is treated with the excess of the NaOH, it will be converted into ammonia. The liberated ammonia will be passed into a known volume of standard acid solution. Okay, the unused acid is determined by back titration with NaOH solution. From the volume of acid used by ammonia liberated, the percentage of the nitrogen in the coal is calculated. The percent of nitrogen is the volume of acid used into normality of acid into 1.4 by weight of coal sample taken. We can understand better the determination of nitrogen by seeing this diagram. Here, it is a long-necked flask. It is called the Jaldal flask, in which we will take the coal sample and it is treated with the concentrated sulfuric acid and CuSO4. Here we will take the potassium sulfatate, so K2SO4. This K2SO4 will act as the boiling point elevator. Boiling point elevator means it will enhance the sulfuric acid boiling point. Okay, and here CuSO4 will act as the catalyst. Catalyst means it will only enhance the rate of the reaction. It won't participate in the reaction. Okay, here the CuSO4 will act as the catalyst. K2SO4 will act as the boiling point elevator. It will enhance the boiling point of the H2SO4. It will enhance the boiling point of the H2SO4. Means when the coal sample is treated with the sulfuric acid and the CuSO4 along with the K2SO4, it will be converted into a clear solution. This is a long necked flask. It is known as the Jaldal flask. Afterwards, this clear solution is transferred into another flask in which it is treated with the NaOH solution. Here, after treating this clear solution with NaOH solution, the ammonium sulfate is formed in this clear solution, ammonium sulfate. It will be converted into the ammonia. It will be converted into the ammonia gas, which will be collected into a known volume of the standard acid solution. Known volume of the standard acid solution. After that, the ammonia will be neutralized with the acid. Ammonia plus acid. It is a known volume of acid, means the volume and the normality of the acid is known for us. They will be neutralized. Okay. The leftover acid will be known by using the back titration with the ammonia NaOH solution, sodium hydroxide solution. Okay. Next, we will calculate the percentage of nitrogen by using the formula 14 N by V, the known volume of the normality and volume into 100 by V by 1000. After the simplification, we will get the 1.4 into normality into volume by weight of the coal sample. Therefore, the percentage of the nitrogen in the sample can be calculated as 1.4 into normality of the acid and the volume of used for complete neutralization of ammonia. Whatever the acid used for the neutralization of ammonia, that volume we will take here, and the normality of the acid we know. We will take the known normality of the acid by weight of the compound taken. If we substitute these values in this formula, we will get the amount of the nitrogen present in the coal sample. This is how we will calculate the amount of the nitrogen. Next, sulfur. A known weight of the kern is burnt in a bomb calorimeter in a current of oxygen where the sulfur is oxidized to sulfates. Means we will take the known volume of the known quantity of the sulfur and it will be kept in a bomb calorimeter where the oxygen is provided. Then the sulfur present in the coal is converted into sulfates. These sulfates, upon treatment with barium chloride solution, they will be converted into barium sulfate, which is a precipitate. Okay. The sulfates which upon treatment with the barium chloride solution, they will be converted into barium sulfate. Barium sulfate is a precipitate. This precipitate is filtered, washed and heated to get the constant weight. Okay. Until we will get the constant weight, the procedure of the filtering, washing and the heating will be continued. After we will get the constant weight, we will stop the procedure and we will calculate the percentage of the sulfur by using the formula weight of the barium sulfate obtained into 32 by 100 by weight of the coal sample taken into 233. Here 32 is the molecular weight of the sulfur and 233 is the molecular weight of the barium sulfate, which is the precipitate. Okay, this is how we will calculate the sulfur. And next, oxygen. Oxygen is calculated by the percentage of oxygen equal to 100 minus percentage of the carbon, hydrogen, sulfur and nitrogen. If we will minus the percentages of the carbon, hydrogen, sulfur and nitrogen by 100, then we will get the percentage of the oxygen. This is how we will calculate the elementals present in the coal like carbon, hydrogen, nitrogen and sulfur. Now coming to the what is the significance of the ultimate analysis. The carbon and hydrogen, greater the percentage of the carbon and hydrogen, the better is the coal, means it is the good quality of the coal. Nitrogen has no calorific value, means the coal should have the less quantity of the nitrogen. And sulfur, it is highly undesirable in the coal. It will cause the pollution also and it will cause the corrosion to the iron metals. Okay. Next, it will form the oxides of sulfur. That is why it is not desirable in the coal sample. And oxygen, a good quality of coal should have low percentage of the oxygen. At last, we will know that the coal sample which has a good coal sample, which we will call a good coal sample, should contain the more percentage of the carbon, and it should not contain the nitrogen, sulfur and oxygen. This is how we will analyze the elements present in the coal by ultimate analysis. I hope you understand the session. We will continue the next topics in another session. Thank you.